Hello, fellow Unreal developers. This video is about setting up a project with Unreal 5.4's Gameplay Ability System, with the focus on building a base character class that owns the ability system component and two subclasses for player and enemy characters. We will also build a base attribute set and a health attribute set for health, shield, and incoming damage, which will apply to shield before health. Also note that while the Gameplay Ability System has some built-in support for multiplayer scenarios, this already lengthy video will be focused on single player. And a special thanks to all my supporters. Your support is what makes this worth doing. We're going to build this from the ground up using the blank C++ project template. But most of what you see here can be applied to other templates with a few changes. I'm going to name this GG for a gas game. For the most part, some base classes and the gas-related functionality will be added in C++. And the actual gameplay abilities and gameplay effects will be added as blueprints. Now, the first thing I like to do in a new project is go to Editor Preferences and switch this Asset Editor Open Location to Main Window. Also, because I'm used to flight stick controls, I'm going to invert my mouse Y. So for the project, the first thing we need to do is enable the Gameplay Abilities plugin. With that, we need to restart the editor. And I don't want to use this, so I'm going to create a new level. It's going to be a basic. And then I'm going to save that level. I'm going to create a maps folder. And just call it test map. Now when we relaunch, that's not going to show up unless we go into project settings. Under maps and modes, we can then set it in the editor startup map. And also our game default map. All right, and then we need to create some C++ classes. So we'll start with subclassing Gameplay Ability. I'm going to click public here so that it puts our headers and CPP files in different folders. And I'm just going to put GG at the front of each of those. So we don't want to reload the project yet. We want to wait for the live coding to finish. We close that. We go back into Unreal. And we'll do the same thing. This time I'm going to subclass character and call this GGBaseCharacter. And do the same thing. This time we're going to use our GGBaseCharacter to create a GGPlayerCharacter. And once again, the GG enemy character. And then we're going to subclass attribute set. Surprisingly, we'll call this GGBaseSet. And the last one we're creating right now is based on that GGBaseSet, and we'll call it GGHealthSet. And with that done, we close the editor. Make sure there's no red bar at the bottom, and then we can reload. Close all this so we can see our source. And the first thing we'll do is in our build.cs file, we're going to add gameplay abilities, gameplay tags, and gameplay tasks. So in the editor, you had to add gameplay abilities so that the classes like gameplay ability and attribute set would show up. Similarly, in C++, we need to add these for the relevant classes to be found. And then in our base header file, I'm going to add an enum. This will be needed in our gameplay ability class for the enhanced input to interact with it. So in here, I'm just going to replace everything. So all that was added here was we have our ability input ID, which is that type, initially set to none, and a accessor, a getter, to return it. Next, in our BaseSet class, we define a convenience/utility macro here. This macro is basically taken from attribute set way down here. And a little explanation of what it does. And we're overriding pre-attribute base change, pre-attribute change, and we're creating our clamp attribute on change so that it can be overridden in the health set. In our BaseSet CPP file, we are just calling clamp attribute on change after calling the super functions for both of these. In our health set, we're first including the ability system component, and that is so we have access to our multicast delegate. So there's variations of this from 1 to 7 or 8 parameters. We're naming the delegate, and then these are the values that we're sending to it. The last one being damage. We're creating attributes for health, max health, shield, max shield, shield regen, and incoming damage. And then we're creating a variable for the delegate up there. So you can see here the attribute accessors was using this macro. So what that is doing is creating a bunch of utility functions like get, name, attribute, and getting the value, and other useful stuff. We're overriding our clamp attribute on change and post gameplay effect execute. And we do that so that in our health set code, we can use clamp attribute on change to check which attribute is being changed. If it's the health or the shield attributes, then we are clamping them to or between 0 and the max values. Max are all the attribute values are being set up here. We have our health being set to 40, max health to 60, our shield and max shield to 0 and 50, and our shield regen to 5. When gameplay effects have changed an attribute value, this function will get called. In this case, we are checking to see if it is the in-damage attribute. When it is, we're going to get that value, set it back to 0. As long as it was greater than 0, we're going to call this on damage taken delegate as long as something has bound to it. We'll show you where that gets done later. In that case, we're just broadcasting to that delegate the instigator and causer, which are usually the same, but not guaranteed. We're sending along our gameplay tag container, and the data evaluated data magnitude is effectively the same thing as in damage done. We're then checking to see if the character has a shield. If it does, then we will get the new shield value based on the damage done. reduce the damage done based on the shield value, and then clamp that shield value back to its 0 to max shield. And similarly, as long as there's still damage left over to do and health is greater than 0, we will calculate the new health and apply it to the health. In our base character, we're going to include our ability system interface so we can inherit from it. Gameplay effect types so that we can use some types down here like the gameplay tag container or the on attribute change data. So what's happening in here? We're inheriting from character. So we're getting the character mesh built in. Then when we're defining the ability system component, we're defining our health set that we just created. And then we're adding 2 arrays, one for default abilities and another for default effects. We have a constructor, and then we have the get ability system component is required by this interface. Actually, that is the entirety of this interface. And all that's going to do is return this value. We create functions to initialize our abilities and our effects. We do some other stuff in post-initialize component. And then we have functions for on damage taken, which is just the delegate we created in the health set. There's a combo of 2 of these, each for the damage taken, and then there will also be when health attribute is changed, shield attribute is changed, and that's because these versions, that one, and this one, will be the one that the actual delegate that's called, and each of those will just be forwarding to a blueprint implementable function. And here we're including ability system component instead of interface because we need that here. And our gameplay ability that we created, our health set that we created, so that in our constructor we can create both our ability system component and our health set using the usual create default subobject functionality. In begin play, we are subscribing to the on damage taken delegate and having it call this function. Similarly, this is how we subscribe to attribute changing. We need to send along the attribute and then the function. As I said, get ability system component just returns that. In our initialize abilities and effects, in both we're making sure the ability system component is valid, and in the case of abilities, it's only on the server. With our default abilities, we're just iterating through that, and we are using our ability system component to give the ability. And this is where we have our abilities, get ability input ID. Similarly, in initialize effects, we are iterating through our default effects array. So first we use our ability system component to create a effect context. We iterate through our default effects, and for each of those effects, we're going to make an outgoing spec using that effect context and the effect. And then we use our ability system component to apply that gameplay effect spec to self, sending along that spec handles data. Later in blueprints, we'll see something that looks very similar to this. And then, like I said, our 3 delegate functions are just forwarding to the blueprint version. Lastly, the actual setup for initializing our gameplay ability system component is in our post-initialize components. In both cases of player and AI, this gets called. We're just checking again if it's valid and calling init ability actor info. So this is sending along the owner and the actor. Those things are both the same in the case where the ability system component is attached to the character. In the case where it's attached to something like a player state, then this would be the player state and this would be the character. We're then calling our initialize effects and abilities to have those applied to the character. For our last class, our player character, we're not including anything special. However, we have all these classes defined up here, but we did not have them defined up there in this case. So the reason that is because it's effectively functionally the same. You can choose one way or the other. But when we're using our ability system component or our health set, we're saying class here. So we could have done the same thing. This is just telling the compiler that our health set is a class, and we need that information if we're going to use a pointer to it. So in here, our player character and our enemy character both subclass from base character, so they get all that functionality. For the player character, we're adding a spring arm and camera. A lot of the functionality in the player character class may look familiar because most of it is copied from the third person character template. So we have our spring arm component, our camera component, and for enhanced input, we have our mapping context and a few actions. In this case, it's for jump, move, look, and the one we're adding for the gameplay ability system is FireAbility action. We have a constructor, begin play. We have our look and move functions, which is what will be connected to our look and move actions. Jump action will be calling a parent, character parent function. We're creating send ability local input. This is where we're actually sending the information to our ability system component. We set up our player input component, and we have a function FireAbility, which is just going to call send ability local input. So the code for that, quite large. So again, most of this is copied over from the third person character, but in our constructor, we're setting up the some initial values and components. So then I'll go down here a bit. We have our setup player input component. We're getting our player controller and the enhanced input local player subsystem using that player controller so that we can call add mapping context and with our supplied default mapping context, which will be set up in Blueprint. Similarly, we're getting our enhanced input component to call bind action on a bunch of actions. So we have our jump actions where when it's started, which is when you press spacebar down, it's calling jump. When you release, completed is called, and it will call stop jumping. Move action and look action, we'll just call move and look. And FireAbility action is calling our FireAbility function. So back up here, we have look and move, again, just copied from the third person template. But basically the value that's sent in here is the mouse XY value, and we're using that to change our controller's yaw and pitch input. And similarly for move, we're getting our value, which is sent in as a 2D vector, and it's just being used to add a move and input for forward and right directions. Our FireAbility is sending along the bool value, along with the enum value for this FireAbility. And that is in send ability local input here. So as long as it's an ability system component, we are getting the value as a bool from value, and we're just calling ability local input pressed or released, depending on whether that's pressed or released. Lastly, the enemy character is not getting any changes, so all of its functionality for now is coming from the base character. In the future, you might want to add some utility functions or similar. We'll hit F7 to compile that. Visual Studio will tell me that I messed up my copy pasting. So I did a prep project before this and I forgot to take the word prep out of all of this stuff. Oops, that's not mine. Yeah, I prepped GG API. And some of those I replaced and some I forgot. So I need to replace all those. F7 again. I guess the includes. And lastly, what do we got? Oh, another prep. All right, so with that done, we will launch the editor. So first off, I will create the input stuff. I'll create a folder for characters. In that folder, I will create an input folder. And in that folder, I will create input mapping context. We'll call that IMC default. And then going to create input action. We'll call this IA look. Open that up. The default is that it's set to bool, like a click or a button press. We want to switch this to axis 2D. Our IA move, I'll duplicate this, rename it IA move, is the same setup. However, I will then create another input action. This one is input or IA jump. In here, it's using the default bool, but because we saw in the code that jump needs both a pressed and released, we need to add those here. Similarly, the fire action, we will just duplicate this one. IA FireAbility. That also needs the pressed released in case you want to have released inside of your gameplay ability. Then we open up our IMC. We're going to add mappings. First I'll add look. This will be the mouse XY, so we go in here, mouse XY. Now if you want your Y inverted or not, you can go in here, add a modifier for negate, and then you want it only for Y. Similarly, we'll add IA move. And here we have our WASD. For W and for S, we need to add swizzle. So this is basically converting our X to Y or Y to X. And then in our D, we again need that swizzle. But we also have negate. Now this has X, Y, Z all applied. It doesn't actually matter because it's only going to be using the one value. And then here we have A, which does not need swizzle, but it needs negate, making it negative. And lastly, we have D, which has no modifier because that's the default XY value and it does not need to be negated. Now I hate this UI because even though I close that and I hit that, it pops it all back open. And then we add jump, which is just space. Lastly, we add our fire ability, which will just be left click. Next, since I started with a blank project and not the third-person project, I don't have the mannequins. So I'm going to go into the Epic Launcher, find Mannequins pack. So in the launcher here, we want to be on Unreal Engine. We can go to Marketplace, search for Mannequins pack. As long as it looks like Manny and Quinn, then we can add it to our project. It may claim that there's some files that already exist. That's okay, you can just replace them. And now you can see the control rig folder was added. So in our characters folder, I'm going to create a blueprint. This will be our player character, so we want to go to all classes and type GGPlayer. I'm going to call this BP character. And in here, first I want to set our skeletal mesh to Quinn, simple, and our anim class to ABP Quinn. In our mesh here, we want this down 95, and turned -90. So for whatever reason, if I go down a little low, you can see at -95, the feet and the bottom of the capsule line up pretty well. We'll see why I'm calling that out in a little bit. And then in here, we can do a search for input and set up all of these. So this is our IMC default. It's our jump action, move action, look action, and FireAbility. And now to get our character actually in the level, using the player start, we want to create a new blueprint class for GamePlayBase. We'll call this BP GameModeBase. And in here, all we need to do is set our default pawn to BP character. Oh yes, that little tick means it's not saved. So what I like to do is in here, I'll go save on compile always. So now I just need to compile and it saves it. I don't have to click that every time. So similarly with the character. And then because we want this set up for everything, we can go in our project settings, do a search for game mode. And under default game mode, we can choose the one we just created. And so we hit play and our character. So looking around works, moving around works, jumping works. The default jump is very odd looking, but it works. So even though you can't tell, when I put in the mouse invert Y, moving the mouse up is actually going up. So it's actually the opposite of what a lot of people consider invert. And again, I like mine light stick control, so I will go back into look here and just remove the negate. Oh yes. All right, so if I hit tilde, top left of the keyboard, in here I can do show debug ability system. You can see the attributes that we set up. So our health is 40, our max health is 60, etc. So with that, I'm going to create our first gameplay effect. I'm going to create a folder. I'm just going to call it gas. In there, I'm going to create abilities and effects. And here I'm going to right click, create blueprint class for gameplay effect. And just call this GE default attributes. So in here, I'm going to add two modifiers for health and max health. They are both going to override, and the value will be 100. In our character then, I need, in our default effects, add this here. So now when we play, that initialize effects will get called. And you can now see that the health is 60 and the max health is 100. So you may wonder why health is not, or 100 as well. It's because when I set health to 100 initially, max health is set to 60, the clamp attribute gets called and it sets it to the maximum of 60. And then it sets the max health to 100. So when you're setting up stuff like that, you want to just make sure your max health happens before your health. All right, for our second gameplay effect, going to create GE Shield Regen. So in this case, we want it to be an infinite duration because it's also going to be applied at the beginning. It will have a modifier to shield. It will be add an interval up here every 1 second. And the modifier magnitude that will be happening will make this attribute based. Our backing attribute will be our shield regen. Now, if you want to keep the math simple, I basically have the shield regen value set to 5, and I have a period of 1. The coefficient here is also 1. So you typically want your coefficient and your period to remain the same. Right now, every 1 second, I get 5 times 1 regenerated. If I set this to 0.2 and 0.2, then it would be every 1/5 of a second, it would be 0.2 times the 5, which would be 1. So if I add that here as well, hit play, go into the show debug, you can see that the shield value is going up by 5 every second, and it'll stop at 50. You can also see that our health and max health are both 100. And for our last gameplay effect, we'll create GE damage. So similarly, this will be an instant effect. It is going to affect health, and it will be adding -20. So to show this off in our event graph on our character, I'll just add attached to our IA jump. I'm going to get the ability system component, control drag that for the get, and I want to use apply gameplay effect to self. The effect is our GE damage, and this will just happen every time we press space. Oops, gotta run first. So our health is 100, our shield is going up, hit jump, and health is reduced by 20. So that directly affects health by -20 each time, but we wanted our mechanic to go to shield before health. So in that case, we're going to set our attribute to in damage. We're going to change our float value to SetByCaller. And for SetByCaller, we need to attach a tag. So in here, we can click the button, or the plus button. We'll type damage.setByCaller. And we need to make sure a source is selected. And add new tag and select it. And now in our character here, don't need that. We're going to use our ability system component to make outgoing spec, just like we saw in C++ earlier. It will be for this GE damage. We use that to call assign tag SetByCaller magnitude, send along the tag we just created, and send along the value. Now the other part of this is that we added -20 to health. In this case, we're applying 10 damage. So it doesn't need to be negative. This also goes in started. And then we use that ability system component to apply the gameplay effect spec to self. Now when we jump, you can see the health value go down. As long as shield is 10 or less, well, I guess less than 10, it'll apply to health as well. Now it might be convenient to hook this up to some user interface. So for that, I'm going to create another new folder. I'll call it UI. In that UI folder, I will create a user interface widget blueprint. Click user widget type. We'll call that WBP HUD. For convenience, I'm just going to throw everything in this one widget. First, we start with a canvas panel. And inside that canvas panel, I want a vertical box. Inside that box, there will be a progress bar. We'll make this vertical box in the bottom left. We'll put that at 20, negative 120. We'll make it 400 by 100. This will be health bar. It needs to be a variable. And because I want text on top of the health bar, you can not just drag text onto it. Instead, I'll right-click the health bar. I will wrap it with an overlay. And then I can drag the text onto the overlay, and it will create the health bar and the text on top of it. For the overlay, I want to fill the vertical box area. For the text, I want it centered, and it also needs to be health text and a variable as well. The health bar, we want to fill that area. And then I can just duplicate that section. We'll call this shield bar and shield text. I'm just going to change the health bar to green. The shield already has a nice color. Actually, I feel like shield should be on top of health. And lastly, for aiming convenience, I will throw an image on the canvas panel. I will make that 8 by 8, just a small square. I will hold Control and Shift so that it's in the center and the anchor is in the center. Lastly, in our graph, I'm going to create a few functions. First, we have update bar. This is going to accept a value of type float, a max value, and then I'm just going to duplicate that to save some time, call that update health. And then back in our update bar, I want another variable for the text and the progress bar. So if you're not sure what type text and progress bars are, which incidentally are text and progress bar, you can use this little trick to do it. If you right-click in your function, you can add a return node. If you take out your health bar here and health text, if I drag that onto the return node, it'll add an output parameter, and I'll do that for each. So that in our update bar here, we now know that the one type is text and the other type is progress bar. I'm just going to call this text control and bar control. Change this to text, which is way down here. Too far? There we go. And progress bar. We can get rid of we can get rid of all that. Get rid of the outputs. Okay. And in here, we're using our text control to set text. So instead of dragging that out anytime you send in a parameter, you can also just right-click, type get, the name of the variable. That's a little more convenient when you're way over here. So we're calling set text. And I'll be sending along text, but it needs to be formatted. If you drag that out, there is no append. So instead, I want a string append. I can remove that, and that gives me a string append. It will auto-convert it with a convenience function. And in here, I just want space / space. I'm sending in the value and max value. And then I'm using get bar control to call set%. And in that case, I can use get value, which is going to be the variable down at the bottom, get max value, and just subtract or divide. More robust logic would make sure that max value is never 0. Which is something I encourage you to do on your own. With that set up, the point of our update health function is to call update bar with the values and sending along the appropriate controls. Similarly, I can duplicate this, call this one update shield, and replace it with these. And so in our character, we can create our forwarded on health changed event that is sending along the new health. However, we want both the health and the max health for that. So then I'm going to create a function in here, also called update health. In here, we're getting our ability system component to call get gameplay attribute value. This is how we get, well, this is one of the ways we can get our attribute values. You may notice that when I drag that out, that's called get gameplay attribute value. So if we have gameplay attribute value, you're like, why is there no set? That would be convenient, but setting attributes is almost entirely through gameplay effects. So copy that one down here for max health. We need to, in our begin play, we're going to create the widget. This will be our WBP HUD. I'm going to save that as a variable. Let's call it WBP HUD. And then we want to add that widget to viewport. So that we can get it in here and call update health. Similarly, we'll just duplicate that, call it update shield. We'll switch these to shield and max shield. Switch this to update shield. And now we can call update health. And similarly, for our on shield changed, we'll call update shield. Now we also need to forcefully call update shield and health at the beginning to get that UI to update. So we can just call it up here. There we have our shield and health with the shield regenerate. Next, we can create the enemy character. Similarly, this will be from our GE enemy character. We'll call it enemy character. And for this one, we will add Manny. And ABP Manny. This also needs to be -90. However, if we put this at the -95 we used for Quinn, you can see that is too low. We'll pop that up to -88. In the case of the enemy character, we are going to add our onDamageTaken event. Sends all that useful information. We will just print out using string append the damage and that it was caused by that target. And to damage that enemy, we are going to create an ability. So as a reminder, we have Gameplay Ability, right? But we want to use our version. We'll call this GA FireAbility. And when the ability is activated, this gets called. We are first going to get avatar actor from actor info. So the init ability actor info that we called in C++ is basically what gives us this value. So the avatar again will be the character, so we can cast this to BP character. You only need to cast it to a character or any other class if you need to access bits from that class specifically, and we do. I'm going to promote that to a variable, just call it character. I'm going to call commit ability. So commit ability is a function in the gameplay ability that will spend resources and coordinate with the cooldown. So we won't be doing it in this video, but if you have a cost gameplay effect, and you can see that in one of my other videos, you would create it and you can add it here. A cooldown similarly you can create and add here. We're going to drag out a bool. If I do that and I hit B at the same time, or while I'm dragging it out, it'll give me the branch and hooked up, which is very handy. If commit fails, it will actually call a end ability itself if it's effectively at the beginning of this functionality, but it's still good practice to throw it down here. In that case, I'm going to do a sequence. So when commit ability is successful, it will first do something and then it will call end ability. If you do not call end ability at the end of your ability, activating it again will just not work. So for this, I'm going to control drag out my character. I want to get camera comp. Use that to get world location. And and world rotation. That is all being done so that I can use a line trace by channel. The character by default visibility won't work, so I'm setting this to camera. This will be the start location. I'm getting the world rotation so I can get the forward vector to multiply that by some large number. And when you pop out a multiply like that, it's vector multiplied by vector. You can right click on here, switch it to a double precision float, and I'll set that to 5,000. We want to break the hit result from this so that we can get our hit actor. We want to get a ability system component from that actor, but only if it is valid. We will continue. Close this up to save some room. And as long as what we hit has an ability system component, we want to get our ability system component. There's a number of ways we can do this. We can use our character and call get ability system component. But if we're not using a character, then it is handy to also have this function. Get ability system component from the actor info directly. So we can use that. We're going to make our outgoing spec for GE damage. So that we can assign our tag SetByCaller magnitude. The tag of damage.setByCaller magnitude, we'll make this 10. And lastly, we want to drag out the ability system component to apply gameplay effect spec to target. So you have target, the one that you dragged out from, or the source is the first one, and the target, the actual target, is the second one. Call these bits up. And lastly, the target. Double click it. And again, it's a sequence, so we don't need to call end ability here since it's happening on the second pin of the sequence. But it is important. And with that set up, we can see why we created a crosshair. But I need to add the enemy character to the level. I'll just pop this over at 500, 0. And to make it look more menacing, we'll turn it around. So when we hit play, click on him, nothing happens. And lastly, the reason why we subclass gameplay ability is so that we can set our ability input ID here. So we set this to FireAbility, so that our character, when we hit the left mouse button, the FireAbility action will forward that to the ability system component. And this will only work if in our character, we actually give the ability to it. So similarly, we need to give the ability to our character so that that works. So there we go. You can see that I'm doing 10 damage and it's coming from the character. Thanks for watching. If you liked the video and would like to see more, you know what to do. And if you would like to support this channel or just want to download the project files, you can do so through my Patreon linked below.